Without further ado, I introduce Al, namely in the box over here, and Owen Gingrich.
I'm in a difficult situation with Al watching me as I attempt to read his splendid paper, which was based originally on the slides. He was going to speak extemporaneously. Suddenly, with the change of circumstances, he had to add a text. And with luck, I'll be able to keep the text synchronized with the slides. Eileen Reeves and I ended our book on sunspots with a passage from a letter written by Galileo in 1636, 3 years after his condemnation, to the Servite monk Fulgenzio Mecanzio. The letter is about Christoph Scheiner's book, Rosa Ursina, which had appeared 6 years earlier. After calling Scheiner a pig and a malicious ass, Galileo got to the real issue, the discovery that the axis of rotation of the sun is inclined to the pole of the ecliptic. A discovery, Galileo claimed, equally noticed at the beginning by him and by me. This is a quote. "I'm convinced that I discovered it before him, but I did not have an occasion to speak of it except for the Dialogo. But then let the poor devil realize his bad fortune, for he derives nothing wonderful from this observation, and I have discovered the greatest secret of nature with it. And this great secret which I discovered, and the extreme marvel of which he fathomed after my announcement, is what has mortally wounded him and turned him against me like a rabid dog. For it was my destiny alone to observe so many and such great new things in the heavens, and to deduce from them such numerous and stupendous consequences of nature, of which this one, it can be said, is the greatest. And this wretched man, who for so long held such a precious jewel in his hands, was not able to recognize it." Unquote. Pig, ass, dog, wretched man. You will agree that there was no love lost between Galileo and Scheiner. In Rosa Ursina, Scheiner demonstrated the inclination of the path of the sunspots and to the ecliptic. In order to construct this motion in a geocentric and geostatic universe, Scheiner had to add to the daily and annual motion of the sun around the earth a third motion, a conical motion with a period of a year, in order for the axis of the solar rotation to remain parallel to itself. Copernicus had done the same for the earth a century earlier, and as a matter of technical astronomy, this construction would not raise any eyebrows. But Galileo had seen the cosmological meaning. It was just a hell of a lot simpler to account for the motions of sunspots by leaving the sun rotating on its axis in the middle, while the earth went around it, than the other way around. An argument from simplicity for the Copernican theory. This precious jewel, as Galileo called it, meant little to Scheiner. The centrality of the earth was dogma about which there could be no argument. No, what exercised Scheiner was that Galileo used the argument for the first time in his Dialogo of 1632, which appeared 2 years after Scheiner's Rosa Ursina, in which the sun's axis of rotation is treated in detail. Scheiner felt that this discovery and his convincing demonstration was the crowning achievement of his study of the sunspots. And no sooner had it been published than Galileo used it for his own purposes without giving Scheiner credit. You see why Scheiner was furious. Whether Galileo had in fact discovered the inclined axis before 1630 is an open question, and Eileen Reeves has perhaps shed light on this issue. What I want to do is take a closer look at Scheiner and his work. It would be very difficult to make a martyr out of Scheiner. He was ambitious, stubborn, and haughty. To my mind, not an attractive character. Even before he had finished his studies, he had brought himself to the attention of the Duke of Bavaria, who was interested in Scheiner's pantograph. He would continue to bring himself to the attention of the high nobility in Central Europe. The telescope was the most important event in the mathematical sciences during Scheiner's early career, and within a year of the Sidereus Nuncius, he had a telescope good enough to reveal interesting things in the heavens, although it is not clear whether he had observed the satellites of Jupiter at this point. He did see sunspots, and he seized on them as a possible road to advancement. His first observations were written up in the autumn of 1611. At this point, Scheiner's cosmology was entirely conventional. This was the time when the Jesuit general, Acquavita, issued orders for the teachers at Jesuit colleges to hew close to the natural philosophy and cosmology of Aristotle, the solid doctrine. Scheiner had anonymously written to Galileo, through the office of Mark Velser, about the nature of the moon, arguing in a peculiar mathematical way that the lunar surface was perfectly spherical. And now he had something to say about sunspots. He again sent his work to Mark Velser. Velser was quite happy to publish Scheiner's observations and interpretation, but Scheiner's superiors objected. This was controversial stuff. Scheiner could not attach his name to the publication. He chose the pseudonym Apelles Latens Post Tabulum, Apelles hiding behind his easel. This was not a new thought. He had mentioned this pseudonym a decade earlier as a means of showing caution, but also humility. Velser had Scheiner's results, written up as 3 letters, printed at his own press at the famous Pine Tree. But there was a bit of problem with the illustrations, a problem that was endemic in the study of sunspots: how to present pictorial information in a way that did not bankrupt the author or the publisher. In order to make an argument about the nature of sunspots, one had to depict the face of the sun on successive days. The time dimension, sequence, was a constant problem in scientific representation until perhaps the late 19th century and even early 20th century movies. Directors had to learn what was the best way of presenting chase scenes. And here is how Scheiner solved the problem. With the help of the engraver Alexander Meyer, who a decade earlier had done the plates for Bayer's Celestial Atlas, also published in Augsburg. The solar diameters are 86 and 26 millimeters, and the entire plate, a fold-out page, is 27.5 by 20 centimeters. There's a lot of information in this plate. 39 observations made over the time span 21 October to 14 December. The large figure at the top and the art immediately show that sunspots remain on the sun during the course of the day. Scheiner was in no position to plan the exact time of observation because he was looking through the telescope and had to pick and choose his opportunities: sunrise, sunset, fog, thin clouds, etc. Like a good astronomer, he marked the time and location of each observation. The result is a bit messy, but if one can, and one's mind's eye, rotate the figures so that they are all roughly the same time, one gets a pretty good idea of the motion of the spots. It is a rather good way of organizing the information. Scheiner knew that the small circles affected the shapes and proportions of the spots, but since his argument was that they were not on the sun's surface but were satellites of the sun, the shape, at least, was not so important. Galileo's argument was that they were on the sun's surface and were not satellites. For him, it was important to delineate very carefully the shapes of the spots and how these changed from day to day, and the fact that they were not permanent. He was helped by the fact that Benedetto Castelli had figured out how to project the sun's image through a telescope. So he made tracings on large circles, 12.5 centimeters in diameter, 1 per day. The result is extremely effective, but at a cost. First, this second letter was circulated in manuscript, and making good copies of the tracings took a long time, much longer than copying out the text of the letter. Second, when it came to printing these, the method was very expensive. When Mark Veltzer received this letter, he wrote that it, and Galileo's first letter, should be printed with the 41 tracings. But he wrote, "I think this would involve some difficulty because of the many solar observations that are attached. These could, however, be reduced to a much smaller size, as Apelles had done, so they would take up no more than half a folio." Was this just the kind of pietistic frugality of a citizen of a South German city? Veltzer was perhaps a bit crabby because of his gout, which was killing him, literally, and the Veltzer banking firm went bankrupt in 1614, the year in which Veltzer himself died. Veltzer didn't get it. He was a man of words more than of pictures. But the price of illustrations in books has not decreased over the past 4 centuries. The number and sizes of pictures in a book are negotiated in publishing contracts, and I offer you a sample of the first set of page proofs of the sunsets that Eileen Reeves and I received in 2009. 6 to a page, in a space of 18 by 11 centimeters. Federico Chesi, who oversaw the publishing of Galileo's sunspot letters, did get it. High-quality pictorial representations were high on the agenda of the Lincei. Galileo moved on to other projects. Scheiner, convinced by Galileo that spots were very near or on the sun, remained focused on the sun. The sun is elliptical on the horizon, and in order to investigate this effect quantitatively, Scheiner designed a special instrument for projecting the sun's image. Here shown horizontally for horizon observations, and a tilted arrangement for the sunspot observations. Through students and colleagues, he organized sunspot observations in several places in Europe, directing the effort from Ingolstadt when he was there. When Charles Malapert of the Society's College in Douai spent time in Ingolstadt, Scheiner taught him how to project the sun's image. This setup he used in 1618 to observe the sunspots in Douai. Scheiner was giving his superiors some problems. He kept publishing on astronomical subjects, careful always to present himself as a mathematician, not as a philosopher, but usually discussing the same subject close to the cosmological bone. By 1615, the general of his order had decided that any future publications had to have permission from Rome, not just the provincial authorities. And he was increasingly busy attending to the high mobility, traveling with them in style. At one point, Witellewski wrote to him that he had heard that Scheiner had moved to Vienna in a coach with 4 horses and 6 boxes of books. Witellewski told him that he, for a trip to India, would only need a mule and a saddlebag. Poverty was not Scheiner's style. In 1623, Scheiner landed in Rome. Here he lived in the Jesuit house, but spent a lot of time in the Collegio Romano. Here he took up his solar observations again and began to compose his major work. The observing apparatus had become standard, and so had Scheiner's method of presenting the data. As shown earlier, Malapert's observations of 1618 already showed how observations on successive days could be shown, so that the entire course of a spot across the face of the sun could be shown. Thus, stretching the time dimension from Galileo's day for a single engraving in 14 or 15 days. But as Malapert's presentation, illustrations, quality, and size, they do matter. This is a crude woodcut. I must be out of sync here on the slides.
Go back 4. I think go back 4. Another, yeah, that.
This is a crude woodcut, and the sun's face is about 6 centimeters in diameter. One can use such an illustration to argue just about anything, as Malapert was to do that 2 decades later. Small woodcuts just would not do, the more so if Scheiner was to trump Galileo's observations. Scheiner boldly went where not even Galileo had gone before. More than 2 years of his solar observations, over 2,000, made from 1624 to 1627, were represented in 70 high-quality copper-plate engravings 21 centimeters in diameter. There were also a number of other engraved illustrations, often repeated 3 or 4 times, but these illustrations were, as Mark Veltzer had already pointed out 15 years earlier, expensive, and there was also a multiplying factor. To get such large illustrations on one page, the book had to be in folio format, and anyway, when Al discovered that I had a copy of the book, he asked if I would bring it along just to show you how bulky it is and to get an idea of the number of these big plates. It's full of them. It must have been very expensive for all of the copper plates required. Well, can you see it, Al?
Yes, I can.
Oh,
Yes, I can.
okay. Multiplying factor 2 was that Scheiner was verbose. Where one word or phrase would suffice, he used 20 or 50. The project grew and grew, and Scheiner had a hard time letting go of his manuscript. But who would pay for all this? Enter Alessandro Cardinal Orsini, a great friend of the Jesuit order. The cardinal guaranteed the cost of the book, and Scheiner spent freely. But the cardinal died, and his brother, Paolo Giordano II, Duke of Bracciano, demanded 300 copies of the book to offset the publication costs. By 1627, Scheiner had already spent 500 scudi, and only book 1 had been printed. For the rest of his life, Scheiner dwelt with the fallout. He was constantly in money trouble. It took 4 years, lots of revisions, added pages, errors that happened when Scheiner could not be present in Bracciano, to produce the 784-page tome, Rosa Ursina, the Ursinus rose named for the Orsina family. I think I've probably skipped too far ahead because here you see the dedication, you see the little bears down in the bottom, a pun on the Orsina name. Here you can see the name of Mutius Vitelescus up there near the top, and in the very bottom line you can see Nicholas Riccardi, who was also the censor of Galileo's Dialogo. Now, a lot of things can be said about this book. Scheiner goes over the top in his dedication and professed gratitude to Duke Paolo Giovanni II. He spent over 60 pages rebutting the claims of plagiarism that Galileo had leveled against him, referring to Galileo as the censor. In Book 2, Scheiner describes the method of observation, 80 pages. Book 2 contains the observations themselves, 200 pages. And Book 4, he explains what all this means. The last book is a bit of a grab bag because it also contains measurements of the solar diameter and a long exegesis on how imperfection and the fluid nature of the heavens find support in the Bible and the works of commentators and philosophers. Note that Scheiner coordinated observations in other places, such as Ingolstadt, Douai, and Freiburg. The first thing that the reader notices is the size of the plates, 21 centimeters, and the details in the sunspots, the black centers, the lighter umber around them. Faculae, the bright spots, are represented here as well. The path of the sunspots is very clear, except at the limbs where there is a bit of a mess. More about that in a moment. A lot of space is taken up by other information. There are 2 roses for the Orsini family in the Jesuit logo. Scheiner is claiming the sunspots for the Jesuit order. Do we really need to know that this observation was made in a Jubilee year? And is it not enough to indicate the city? Must we know that the observations were made at the Jesuit house or the Collegio Romano? And why does Scheiner have to indicate that the path of the spots is the same, direction-wise, as in early years in the same month? And then there's a very useful table, times, dates, and solar elevations. From these, the direction of the ecliptic can be determined. But do we really need that information in the diagram when Scheiner shows the path with respect to the ecliptic? Be that as it may, the area between roughly 30 degrees north and south latitude, where the vast majority of spots do occur, is left reasonably clear to accommodate the pictorial information. Okay, I've gone a little bit ahead, but just on the slides, but we've seen now those big, wonderful plates, and we're going to come to this one in a minute. If we now compare Galileo's tracings with Scheiner's composites, we see that Galileo still had the edge when it came to the shapes of the spots and their number. But the direction of the path on successive days can only be gathered by comparing individual tracings. The direction of the ecliptic, roughly 10 a.m. to 4 p.m., is not indicated. Galileo was interested in showing the shapes of the spots, their changes over successive days, and the fact that they came into being and passed away. Scheiner's purpose, the purpose of his entire book, is to determine the direction of the path from the spots. But if he were to show all the spots visible on each single day, then clearly his illustration would become a confusing mess. So we can conclude that Scheiner basically shows the progress of one large spot, group, as the modern astronomers call it, on each plate. One more example. I referred to the fact that Scheiner's plates, the material at the limbs, look messy. This plate is the best example of that. The spot on the main sequence is shown at a certain magnification, but Scheiner also examined the spot at higher magnification, and he showed the changing shape of the spot in convenient locations around the periphery. I've marked them here for the sequence from 29 April to the 1st of May on the right-hand side of the plate. Either Scheiner did not put them in sequence counterclockwise, or I do not understand the convention of marking the hours. Although Scheiner does show considerably more information about the shape of the spot, it is only an illustration, a sidebar, and it interferes with the clarity of the method of illustration. For the main sequence, time runs from left to right, but for the big spot, it runs counterclockwise. Rosa Ursina is a mess, and it is a treasure chest. Modern astronomers have found that the observations very useful. For historians, the book is almost like a printout of Scheiner's personality, his character, obsessive, compulsive, ambitious, etc. Okay, Scheiner was a sad character, but if we read Rosa Ursina in the context of the Grand Galileo narrative, we can dismiss it in the way Delambre did. He found the book messy and devoid of content, 784 pages long, and not enough material to fill 50 pages. And on the priority dispute, Scheiner's claim, quote, ceases to be excusable when he lacks respect for a man of superior genius, unquote. If, on the other hand, we put the book in the perspective of the difficult position of Jesuit astronomers during this period, we can see it as a brave book. Scheiner does not soft pedal his conclusions, as can be seen in this example. In Book 4, he takes on theologians, discussing scriptural passages and commentaries of the Father and the doctors about the nature of the heavens. They are not perfect and unchanging. They are not solid, but fluid. And he began this struggle in 1611 to 12, at the time when his general Aquavita was issuing letters ordering his soldiers to hew to the line of Aristotle. Scheiner's method of representing sunspots put an end to the notion that sunspots could be satellites of the sun. His colleague Malapert and Douay could massage the spots into satellites. But if we compare his observations with those of Scheiner, for more or less the same dates, in this case, we can understand why no one took Malapart's claim that these were Habsburg moons seriously. Astronomers used Scheiner's method of representing their sunspots in the observations. For example, Gassondi's observations in Provence. Here we see the observations from Hevelius. Organized and thorough as always, he studied sunspots seriously, building a special observatory for observing them. He was a great admirer of Galileo and praised him lavishly for his discoveries in the heavens, but when it came to the sunspots, he wrote that at about the time of Galileo's discovery, quote, Christopher Scheiner, a man of incomparable and universal erudition, was also occupied with observing these spots. In his later published observations, he showed himself to be so diligent that it can be said that he snatched the palm from Galileo. There is no mention of Galileo's Historia e Dimostrazioni of 1613, which appears not to have been widely known outside of Italy. In his influential Astronomie, Lalande discussed the Rosa Ursina in detail, but does not mention Galileo's book. Sunspots became very rare after Hevelius's initial observations. By the 1670s, it was a rarity to see one, such as the one communicated by Gran Domenico Cassini in 1675. Now we've skipped up to Descartes, who mentions the sunspots. He's one of the few putting it into a cosmological setting. Since the discovery of the 11-year cycle in the 19th century, however, and the grand new astrophysical methods to study them, sunspots have been of great interest to astronomers. And at present, they have a reasonably good record of solar activity going back to the early 17th century. This slide shows the nature of the solar activity. My colleague, Rob Van Gent, who recently prepared this version of the graph, added a bar at the top that reflects on a scale of 0 to 1, the density of observations that astronomers have collected from the historical record. The so-called Maunder minimum of solar activity from 1650 to 1710 is clearly shown. In the bar graph at the top, we can see that we have excellent records for just about the entire 17th century, but there is a great observation minimum in the first half of the 18th century, when the solar activity was very high. In the end, would a modern astronomer interested in solar activity prefer to have the record as Galileo represented the spots, or rather as Scheiner did? My feeling is that he or she would prefer Galileo's method because it is more complete. But then I looked at the way sunspots are counted using a method that goes back to the Swiss astronomer Rudolf Wolf. It is a counting method in which the sunspot group is weighted 10 times as heavily as individual spots. Scheiner usually ignored smaller spots, but never the groups. So in terms of the modern sunspot numbers, the difference between the presentation methods of Galileo and Scheiner is negligible. Give Scheiner his due. Sorry, Al, I didn't have time to insert the next graph, which shows, interestingly enough, that the most recent observations coming up to the present time shows that the next maximum of the sunspots seems to be coming in short, as if maybe the sunspots are dying away again. Maybe we're going to be facing another Maunder minimum. Who knows what the sunspots will be like in the coming days. So give Scheiner his due. That's Al's parting shot.
You just heard from Owen is a much better paper than the one I wrote.
So maybe I'll assist the Cyber Al in calling on people, but then he'll address you directly. Are there questions or thoughts? Yes, please.
Yeah. What was the effect on Galileo's legacy when the Maunder minimum happened, and on the solar research in general?
Question is, how did Galileo respond to the Maunder minimum?
Well, he couldn't, he was dead.
Galileo basically was through with sunspots by 1613 in terms of research. And so he never even noticed that the sunspot activity was decreasing, or actually that it was varying, because the Maunder minimum started after his death anyway.
But what was the effect on his legacy when that was?
Oh, did it change the legacy of Galileo's discoveries when the sunspots petered out, maundered out?
No, I think it's fair to say that 20th century astronomers looking back on the beginning of the 17th century, the Maunder minimum actually amplifies the achievement of both Galileo and Scheiner. I mean, the sunspot records that they created were terrific. And they're very usable in modern science.
So, Al, the question has two parts. The first has to do with the angle of inclination of the sun's rotational axis relative to the ecliptic by 7 degrees. And the first part of the question is, I'm not sure what you mean by the purpose of that, but how does that relate to the apparent motion of the sunspots? Is that your question? So the questioner was asking to just connect more explicitly the rotational angle of the sun relative to the ecliptic and the apparent motion of the sunspots. And the second question is a modern one, and that is, how does CO2 relate to sunspots?
Okay, let me answer the first question. Scheiner plotted the motion of the spots very carefully. In his observations, he always had a plumb line, so that he always had the meridian, he had the horizon, he could determine the angle that the ecliptic made at that particular time. And so over a long period of time, he made so many observations in a very precise way, and he taught others to do that, that he could actually say, on the basis of thousands of observations, that he had never measured an inclination less than 6 degrees and more than 8 degrees. So he settled on around 7 degrees. So that is the path of the sunspots. The direction of the sunspots is along the equator of the sun, and the equator of the sun is inclined to the plane of the ecliptic. I don't know whether that answered this question, but that pretty much exhausts my astronomical knowledge. Okay, second part.
The second part is a modern question, which is if you have any comments on the relationship between atmospheric CO2 and sunspot activity.
I could talk for a while, but I think no, the answer is actually no. It's really completely outside of my ken.
Nick Wilding's question.
Hi all.
Hey, Nick. Nice to meet you.
Nice to meet you. So we know from Tom Mayer's partial census of Galileo's Historia that this was a book with 2,000 or 3,000 copies sent out, maybe 1,000 of them pulped. And there's very, very, very little evidence of use in the sense of marginalia. A few copies have these weird attempts to make sense of Galileo's representational technique by pushing pinpricks through from one page onto another so that you basically translate Galileo's technique into Scheiner's technique. Is there any evidence that anyone apart from Galileo read Scheiner? And what's the kind of reception history of the Rosa Ursina, either in the Jesuit order immediately after publication or in the wider scientific community?
Well, I think that for anyone interested in sunspots in the 17th century, you went to Scheiner, and only if you happen to stumble across a copy of Galileo's Historia Dimostrazione, you might look at it, but I mean, it's just not really there in study of sunspots. The reception of Rosa Ursina amongst the Jesuits, of course, very positive. The Jesuit writers, for instance, people like Biancani, had been fighting this whole battle, and the slow switch over to Tycho. Are the heavens? Can we say that the heavens are fluid and things like that? Well, when you really want to know about how that stuff was received, you go to Riccioli's Alma Gestum Novum and the Astronomia Reformata, which are really 3 volumes of the same book. And now you're in the middle of the 17th century, and Riccioli doesn't have any problems with fluid heavens and heavens being imperfect. And I see that as a sort of a sign that even within the Jesuit order, Scheiner's views are accepted and no longer particularly controversial. But that was not necessarily true in 1630, and it certainly wasn't true in 1613.
Yes, please.
I have a question about one of the illustrations that was in the middle of the talk, where there were the messy big pictures of sunspots around the outside rim of the sun, and in addition the series of sunspots across the middle. And I was trying to line up the pictures to see if they were the same sunspots, and I couldn't do that. And so it raised the question of whether the changing shape of the sunspot as it went across, and then the appearance of it when it was at the limb was important at all, and why he drew the pictures around the edge of the sun like that in sort of the wrong position. I can't understand what the justification for that would ever be.
Well, in a way, I can't understand it either. But he wanted to find some place to show magnified images of the spots, and in detail how they changed over a period of hours. in choosing this method, of course, he sort of switches the grammar of the whole method of representation, as I indicated in the paper. And conceptually, that's not very elegant. But it's practical, and once you get over your, the sort of surprise, you can live with it. But it's another way of getting information into a plate, rather than cutting separate plates for these magnifications.
Did the plate end at the edge of the sun? In other words, why wouldn't we just draw them out?
I can't hear this, Peter.
The question is, did the plate end at the edge of the sun, and would there have been another way in the square in the outside domain, outside of the sun's perimeter, where this could have been represented differently?
I think in retrospect, yeah, you can say that, but he didn't do it.
Yes, Eileen has a question. I'm just guessing, pointing the computer and hoping you can see people, but Eileen Reeves.
I can see Eileen.
Hi, Al.
She's no fake, but I can see her.
I can't believe we're willingly talking about Scheiner, but I too was confused about the magnified sunspots and how hard it was to read them. But then I thought, what if it's a bid for him to use his, the pantograph? You know, that enlargement and minimizing thing that he invented? So, in other words, it's more information, but in the end it kind of, it's too much, it leads you astray. But the point of it is that he's got this other nifty device that allows you to scale up and scale down gratuitously. Is that too catty?
You get the question?
Eileen, are you asking me that?
Yeah. In other words, is it just a way of using the pantograph, that magnifying the spots, especially if they're not recognizable?
Yeah, I think that somebody, I don't think it was me, but somebody, her name is Lily, and she's very affectionate. Somebody, and it won't be me, should really write a paper on that particular slide that I showed, because I've not really even finished unpacking it in my mind. I think, for instance, that he made those up, that he observed at a higher power, and probably through the telescope, because that kind of detail, I don't see how he could get that on projection on a sheet of paper. And so there's a lot more to it, and but my ultimate question is, why was this necessary? But that gets me back to the entire book. I mean, I look at the book, and I'm sort of a little bit with Delambre in why is this all necessary? It's a great achievement, but I think I might have packaged it a little differently, that book.
Thank you.
Yes.
Is the Orsini who financed the publication of Scheiner's book the same fellow or the same family as the Cardinal Orsini who Galileo enlisted to advocate his tide theory to Paul V, or is that?
Did you hear the question?
Yeah, I'm pretty sure it's the same. It's the same cardinal, because he liked Galileo as well.
Different person, same family, Paolo? Okay. Paolo says different person, same family.
The Orsini family goes back to about the 12th century, and they delivered, at least one, perhaps two popes, certainly a dozen cardinals, and some of whom had the same name. So I couldn't be entirely sure in answering that question.
Well, with that, I would like to thank you, Al, for this above and beyond contribution. I know you've got things you have to attend to back home, and so thank you for doing this. Thank you for writing out the paper so Owen could read it. Thank you to Owen for doing such a good presentation and all your other contributions to the educational side of this event. Thank you to the audience for coming, and if we could give a final hand to Al and Owen for this paper.
Organizers, especially Peter, for helping me do a rather difficult thing, which I had never done before. So thank you, Peter.
A pleasure, and I'd invite you to dinner, Al, but I think Skyping dinner is less good than scarfing it.
Yes.
So with that, we'll all adjourn to the musical event, which will start at 5 o'clock in Science Center A. Sorry you can't join us for that, Al, but I'll see you there. You have a little break, and the sun has come out appropriately enough unto the day. Thank you all.